In this lesson, we're going to talk about ZRemesher. ZRemesher is an automated remeshing tool that's actually extremely accurate and very, very useful. I've found myself using ZRemesher topology for starting a topology in a film pipeline, and even for some small minor props, I've been able to generate a topology using Zbrush and then utilize that in the pipeline, UVing it and pushing it on through for animation and rendering. So it's come a long way since maybe the first iterations of ZBrush remeshing. They rewrote the entire back end of it in 2019, so it's far more accurate, especially for hard surface. So let's take a look at how we use this. Here I've got a Dynamesh mesh. You can see that it is not at all an ordered topology. How do we get from this to this, which is, if we go into solo mode, an organized mesh that's suitable for animation and UV layout? I've also added subdivision levels to this model. If I step up my subdivision levels, you can see it maintains all the details of this Dynamesh, which only has one subdivision level. This is an organized topology which maintains all the details of my high-resolution sculpture. So how do we do this? Let's take a look. I'm going to go ahead and go back to my Dynamesh, my high-resolution model. I'm going to clone this just to get a separate tool. We'll select that from the tool palette so we don't have any other subtools here. I'm going to duplicate this mesh. So I've got two copies of my high-resolution Dynamesh, and I'll turn off visibility on the other one. I'll come down here to Geometry, and I'll open up I'll turn off Dynamesh and then open up ZRemesher. Now under ZRemesher, you see that we've got ZRemesher and then Legacy 2018. That's actually the previous version of the ZRemesher code. If you turn that on, it will use the legacy version. That is simply for backwards compatibility with older meshes that you might have been working with before the code was updated. Freeze border. Now if you freeze border, what that'll do is it'll take any open holes in the mesh and freeze the number of vertices there and force the retopology to maintain that number of vertices. That's good if you're trying to, for example, remesh a head that needs to attach to a body. So you have a set number of vertices that have to be present. Freeze groups will freeze the border of your polygroups. Keep groups detect edges and keep creases. These are all pertinent to hard surface, so we won't be dealing with this on this demo, but we will on the next one. Now, most importantly, we have the target polygon count. I can change this slider, and it's based in thousands of polys. So at 4, it's set to 4,000 polygons. I could use these buttons. I could do adaptive, double the current number, same, or half. Typically, I find it most useful to use the slider itself. Now down here we have adaptive size, and that adapts whether or not non-square quads will be generated. And curve strength generates just how strong your guide curves influence your retopology. So we haven't used guide curves yet, but we will get to that. So in its most simple form, we were just going to set our target polygon count. We'll leave it at 4, and I will click ZRemesher. If you watch at the top of the screen here, it'll show you its progress, and it will start to generate a new topology. What ZBrush does is it looks at the overall shape, and it looks at your target polygon count, and it works out in memory how to get a logical edge flow based on the forms present in the model, maintaining that shape, but also staying within the target polygon count that you give it. That's important. We'll come back to that when we get to guide curves. But suffice to say, it's very, very accurate, a very effective tool. So we'll just have to wait for it to process here, and then it'll come back with a brand new low-res topology. And here it has completed the topology, and you see what's happened is we have a pretty good edge flow, but it's not quite dense enough to support the shapes that I'm trying to get. So I'll undo, and I'm going to adjust. I'm going to set my target polygon count to 5. Turn on X symmetry so we get a symmetrical mesh. And let's go ahead and ZRemesh once again. So if you have X symmetry turned off, you will have an asymmetrical mesh. And that's important if your sculpture is actually asymmetrical. This is essentially a symmetrical sculpture. So I'm not too terribly worried about having to turn off my X symmetry. So if I turn on X symmetry, it'll go a bit faster because it will actually compute one side and then mirror it over, and then your topology will fit fine. Most importantly, I've just increased it to 5,000 polygons. Let's ZRemesh it again. And here we have the new topology. You can see that it's quite nice. We get a nice edge flow around the nasolabial folds, the nose. We could do better around the eyes, but we'll address that in a moment when we use guide curves. So as it stands, this is a pretty good ordered topology, especially if we're just trying to get a lower subdivision level, so we can work with subdivision sculpting instead of being stuck just in Dynamesh. So let's take a look now at how we can get all of our detail back into this mesh. So here's my high resolution. That one was hidden. And here's my newly retopologized version. I will add a single subdivision level. Turn on visibility on the high res. I have solo turned on, so we're only seeing one. Go to the subtool menu, go to project, and just click project all. And it says it has polypaint. I don't need to worry about polypaint, so we'll just say no. What will happen is it'll start to project that newly divided subdivision level onto the hidden high res. Let's divide again and project one more time. Now, if we switch between the high res and the low res, you see that they're almost indistinguishable. It's going to be able to use maybe one more subdivision level. Let's go back and project all again. And there we go. Now, there's really no difference between my projected version and my high res. So if we go back to the projected version and press Shift D, we can step down our subdivision levels and then step back up, and you see that we have all of that sculpted detail captured within those subdivision levels and still an organized base mesh. So let's take a look now at how we can further refine our resulting ZRemesher. I'm going to delete this subtool, the one that we just remeshed and reprojected, and I'm going to go back to this version here and I will duplicate it. So I've duplicated the high resolution, and now I'm going to go back to Geometry, ZRemesher, and I'm going to start using something called guide curves. I'm going to turn on my X symmetry, zoom into the eye area here. Now the eye area will give me a better edge loop if I make it very, very clear that there is sort of a line of demarcation there at the lid area. So I'm going to mask out the inside of the lids, just like so. I need a hard plane change there so the ZBrush algorithm can really tell where it needs to place the edge looping. So let's place this mask up through here. And then we will invert the mask, and I'll take my move brush and I'll just push these faces in. Grab them up, down, just to make sure that we get a nice hard edge there. There we go. Now, I want to use guide curves to tell ZBrush that I need an edge loop that runs around this eye. So I go to B for brush, Z for ZRemesher, and I will select ZRemesher guides. Now, the ZRemesher guides are basically just curves. I'm going to click and drag, and I'm going to draw a guide curve that runs around the eye, just like so. There we go. We'll draw another one that runs up through this crease, around the eye socket, and comes back here and connects. Oops, that one didn't quite work. So let's turn our draw size down so we get more points. It'll be a higher fidelity curve, which simply means it'll be easier for us to draw it on the surface. It's not going to change the resulting topology. So with guide curves, you're just going to draw them like this. You don't have to draw out the entire topology. It doesn't work that way. These are suggestions to the algorithm. So basically, if you've got guide curves, you're telling ZRemesher, look at the total polygon count I've given you. Then, let's set that back to 5. Look at the shape. Do the best you can to get this shape with this polygon count and this edge flow. The first thing ZBrush will throw away are the guide curves. So you may have to adjust your target polygon count to get those accurately represented, or you may have to go in and use polypaint to increase the resolution in that area, which we'll talk about in just a moment. The point is, these guide curves might require some finesse to make them work because it is an automated tool. It's not a manual retopology tool. For that, you would probably want to use the topology brush or some third-party retopology tools where you're actually laying out the specific topology. What's beautiful about ZRemesher is it gives you a very competent, very usable base mesh with a minimal amount of user input and automatically. So let's go ahead and try this now. We've added in our guide curves, set our target polygon count. Now there's curve strength here. I can adjust how much the curves are affecting my remesh. Be careful with this. The higher I set this value, the more it forces those curves to be followed. But it can denigrate the quality of the retopology in other areas because ZBrush is forced to make sure that we get those edge loops. So we'll leave it at 50% for now, and I will just click ZRemesher. You see it starts to process, and let's see what we get. And here's our resulting topology. If we go into frame mode, you see we get a real nice edge flow going around those eyes. Vastly improved just by using the ZRemesher guide curves. Now I'm going to undo this topology, and I want to turn on Use Polypaint. Now Use Polypaint will allow us to paint color onto the mesh to define how dense or how light the remesh will be in that area. So if we mouse over this, you see that if you set the slider higher, it's going to be red, and lower, it's going to be blue. So make sure my brush Z-add is turned off, and I'm just on RGB. We'll go to the standard brush. Use Polypaint is on. So if I paint in here, we'll just give a nice color to that area. And let's lighten that. We could do that by lightening the color there or lightening the color here. You see we get a finer or a lighter red, so we can transition this area. And now let's turn this very, very far down and go to blue. And we'll paint blue here in the forehead. This isn't going to give us a great topology, but the point of this is to show you exactly what these color values do. So it'll be very apparent when you see this. Let's turn it down even further, and you notice that we get an even stronger blue. Now we will run our remesh again, and this time it's going to look at these color-coded areas, and it will adjust the density of faces based on those color codes. So let's ZRemesh, and here's our resulting topology. Let's change the color back to white and go into frame mode, and you can see the areas that were color-coded as red have more topology. The areas lighter red slowly taper off into larger faces, and the areas color-coded blue have very little density. So you can further refine your resulting topology using Polypaint to drive what areas get the most density and what areas get the least density. So that's ZRemesher for organics. Let's take a look at ZRemesher for hard surface, which is actually quite improved since the previous versions. It was improved in the last version of ZBrush 2019. Here we have a piece that was created using project primitives. It's nice, combination of both hard edges and curvature and transitions between the two types of shapes. So obviously this is not an ordered mesh. This couldn't easily be UV'd, and it's just not pretty to look at. It's not clean. We want to get it to this. Here we have a nice clean retopology which maintains the polygrouping, maintains the hard edges, and gives us a really nice workable mesh. So how can we get from this to this? Well, we use ZRemesher. Let's select this. I'll duplicate, make sure that that's isolated. I will go to Geometry, go to ZRemesher. Now this time we're going to use some other settings. I'm going to use Keep Groups. That will keep my polygrouping, and I can smooth the group border with this slider here. I will leave it set to its default value and only adjust it if I have problems along the borders between my polygroups. Now if you have creases, you can turn on Keep Creases. Creases, you'd know if you had them. You either generated them under the Geometry Crease menu, or you generated them in ZModeler if you happen to be using the ZModeler brush to create these shapes. ZModeler we talk about in a separate chapter. It's polymodeling inside of ZBrush, and I highly recommend that you watch that chapter if you've never done it. ZBrush has an amazing set of polygon modeling tools nested within one of the brushes that can be very, very useful. So we don't have creases on this, so I'm going to leave that. We do have edges, turn on Detect Edges, and that will auto-detect hard edges and then drive the topology based on those. Once again, we have adaptive size. I'll leave that at 50%. We don't have any curves, so we won't bother with that as well. We'll leave our target polygon count and then click ZRemesher. It's going to start processing. You'll see it up here with the status bar at the top of the screen. And it's basically looking at these shapes, doing the exact same thing it did with the organic model, trying to represent the shape that we have in the high resolution, using the target polygon count that we've set to get as close to that shape as possible, and also following the edges between the polygrouping. So let's take a look at this result. And here we go. There is our resulting retopology. So you see that we've got a nice ordered mesh. This is all a single topology. It's maintained the hard edges, and it's quite accurate. We're also keeping our polygrouping as well, which can be really handy if we want to isolate things like this and maybe group loop to cut extra edges around these shapes, or perhaps we just want to be able to quickly isolate and organize the model and continue modeling using these polygroups. I always think it's best to keep polygroups anytime you can, because you're invariably going to find yourself wanting to isolate areas for either painting, UVs, or sculpting. So polygroups are good to hang on to. But this is retopology for hard surface. It's hugely improved since 2019. They have actually rewritten the code from the ground up and added these settings, and it's very, very effective. So that completes our look at ZRemesher and retopology. Hopefully this has demystified some of these tools for you, and you can see how you can utilize this and start working with ZRemesher on your own. During the sculpting process, I cannot stress enough how important it is, I think, to leverage the strengths of Dynamesh and subdivision modeling. So if you do utilize your ZRemesher to create a subdivision version of your model, for example here, that maintains all of your details by ZRemeshing and then reprojecting, I think you're going to find that you're able to do much better sculpture, much better form faster. There is an incredible power both in Dynamesh and in subdivision modeling. So if you watch the Quick Start video, watch the Dynamesh video, and watch the Import Mesh video, you'll see sculpting techniques that traverse across each one of those. And I hope that you can see how you can use the strengths of Dynamesh and the strengths of subdivision levels to do the best possible work. And understanding ZRemesher is integral to that. So thank you for watching, and I will see you in the next video.